Good morning, everybody. You're very welcome to Engineers Week here at Dublin City University. This morning we're going to give you a virtual tour of the engineering laboratories. You are now in the Stokes building, and this is where the majority of the activity happens for our engineering students. The building houses two schools of engineering. We've got mechanical and manufacturing engineering, and we have electronic and computer engineering in this particular building. We have approximately 2,000 engineering students that under normal circumstances will be coming through this building on a daily basis, and the majority of their activities happen in the laboratories in this Stokes building. Stokes himself is quite famous for the Navier-Stokes equations, and these are equations that we use for fluid dynamics and various aircraft technologies and so on and so forth. So I'd like to take you on a virtual tour of some of the laboratories now, and let's go. This is one of our first-year engineering laboratories. So if you happen to be a first-year engineer with us, you happen to do a common entry engineering program. So all of our programs take the same content in terms of engineering. One of the starting points for our practical work, and we are very proud of the level of practical work that we do with our engineering students all the way through from first year to master's level. It starts with something like this, which is allowing students to understand how to design components, how to draw components, how to accurately mark out equipment, and also then how to assemble various parts. We don't expect that you would have any ability coming into first year. In this space, we teach you how to use various hand tools. We teach you how to draw. So an example of the engineering drawing will be something like this, okay, where you can actually draw up a level of detail on these components, and then we ask you to go and manufacture them and assemble them. And the final product, in this particular case, for this particular example, is this device here. Okay, so all the components have been made by yourself. All the components are marked out, cut, machined, and so on and so forth, so as that you can get to the final assembly of this particular device. We have a range of components, we have a range of tools in these areas, and all of that will give you a really good first year experience on what we call challenge-based learning. We move very swiftly. You would have that done within the first 6 weeks of your particular program, and we move very swiftly then to bring you into a team. This is an individual activity, but we bring you into a team then that allows you to go to these types of devices here. So when we get to these particular devices, within a team, we are bringing together now mechanical design, electronic design, programming, and we get you to start to assemble these types of devices within a team of maybe 4 students. These particular devices, the challenge is that you have to follow a line here, and we have a series of sensors, and Liam Dominican here, our Chief Technical Officer, will just demonstrate one of these particular devices. So we ask this particular device to move along the actual line using a sensor, and it has to find the actual line before it can actually move. And again, this will take place within the first semester, and then by the end of the second semester, we have a competition for the students in order to compete with the various cars that they have designed. You can also see that the students will have various different designs here, so it's up to you to be creative and innovative in terms of the overall design of these components. Okay, so at this particular point, we will move now to the next engineering laboratory, and I'll take you through some other content there. We have a lot of tools and things like that, that again, the students will use as they're coming through the actual program. And unfortunately, at the moment, we have to have screens for COVID-19 and things within these laboratory areas, but the health and safety of our students is paramount as we go through semester 1 and semester 2 of this particular term. As students then come through in the second year of the program, we are continuing to teach them, various aspects of the engineering. So, we move from, say, engineering design through to fluid mechanics. We teach them about pneumatics and hydraulic systems. And then because, again, we put an emphasis on challenge-based learning, we set another project in third year. And this one has, while it is a product design course, we actually talk about it as the Fireman Project. The students have nicknamed it the Fireman Project. So the challenge on this particular one is, you have a ladder here, which is approximately 1 meter in height. We ask you to design a device that will carry this beaker full of water from the bottom of the ladder to the top of the ladder. The only moving part that you have is a pneumatic cylinder, which is in here, and that just gives you a linear motion, so out and back. And on the basis of that, we ask you to climb the ladder in the quickest time possible, minimizing the amount of water that you're going to spill from the beaker. So as we start to move through this project, and as you start to actuate the cylinder and get some movement on this, the beaker tends to jump up and down. And what we want you to do is to build a damper that will actually stop the water from leaking from the actual beaker itself. In order to get that to happen, you have to come up with a spring damper mechanism, and this is one of the spring dampers that has been designed by the students, and that will minimize the spillage of the water, and then we can speed up the movement of the actual cylinder itself. So just to give you an example of the movement of this particular component, so on the day this will be automated. I'm just demonstrating this afternoon or this morning that this is manually actuated, but it's the movement of the actual device up the actual ladder. You can see that it's jumping, so that's when the damper would come into play, the beaker would be filled with water, and you can see how slow I was on the manual actuation of this. The quickest speed for the movement of this up the ladder is 1.6 seconds. Okay, so the students at the moment that have the record in this, the record is 1.6 seconds on this particular device. Again, the students are in teams, and we do this in order to ensure that when you hit industry, that you are industry ready. And, generally teams of 4 will be working on this, and it's a very hectic kind of design build challenge within the third year of your program. Okay, so we're going to show you a demonstration now of the actual students competing in what we call the Fireman competition, and you will see on the screen now some of that activity.
Hi, I'm Tara and I'm an engineering student at DCU. In 2018, 16 DCU students joined forces with students from other Irish universities to form Team Airloop and compete in front of Elon Musk in the Hyperloop pod competition at SpaceX HQ in California. Dubbed the Olympics of Engineering, this competition involves student teams from across the top institutions in the world, competing, designing and building prototypes of the Hyperloop. So the Hyperloop would involve a specially designed pod which had to travel as fast as it could down a vacuum tube, and this would take place at the SpaceX headquarters in Hawthorne, California. From 700 teams, Team Airloop was one of just 20 to get through to the finals. While most people are familiar with Elon Musk's idea of sending manned flights up to Mars and also to eventually establish a colony there, they're less familiar with his vision for a futuristic transportation system called Hyperloop. So this transportation system would involve the specially designed pods which would transport passengers rapidly through a system of near vacuum tubes. Theoretically, this technology could transport you from Dublin to Galway in just 11 minutes. While Team Airloop were not able to win the competition, they did come 5th and received an innovation prize for their efforts. If you'd like to follow me, I'm now going to go to the electronics lab. So this is the electronic lab at DCU. The School of Electronic Engineering was established in the 1980s, and its educational programs have remained at the cutting edge since their inception. Recognised both nationally and internationally for outstanding quality, their programs are focused on preparing students for a wide variety of careers in the ICT sector, including computing, electronic and mechatronic engineering. Electronics students get a combination of both lectures and practical programs, so they will have full access to the facilities that you see here. These labs will allow them to complete their work both individually and as part of a group, and they are used to develop their ability in modelling and analysing the dynamics of a wide variety of technological systems. They are also important in making sure that they're learning a new creative and innovative way of problem solving. The staff at DCU have created a very supportive learning environment for students. At any time, there is always an engineer or a technician who is more than willing to help you out whenever you need it. DCU pride themselves on having a very hands-on learning experience from the very beginning. So whether it's building a circuit or designing code, basically studying engineering at DCU means that you are developing and using your knowledge and skill from as early as first year. Please find out more about electronic and computer engineering at DCU by visiting www.dcu.ie.
In 6th year, I liked biology and maths, but I knew I didn't want to do either on their own. So I asked a few teachers for advice, and one pointed me towards engineering. At first, I didn't even think I could do engineering because I didn't do it for my leaving cert. But after some research, I found out I could, and engineering seemed like the perfect fit.
Our program is unique in that it offers a choice of majors in 4th year. These majors are aligned with the needs of industry and society. Our program includes a paid 6-month intra-work experience in 3rd year. You have a good chance of gaining experience in multinationals such as Google, Microsoft, IBM, and SAP.
In 1st year, I did common engineering, and I had intended to do biomedical engineering because I liked the idea of combining biology and maths. But then I was introduced to electronics and programming, and I was hooked. I liked the process of analyzing circuits and looking at systems and understanding how they worked. This course was great because it gave me the opportunity to explore all branches of engineering and explore what I really liked.
It's no surprise that 33% of the CEOs from the world's biggest companies have an undergraduate degree in engineering that is higher than any other discipline. Graduates from this course are highly employable both at home and abroad.
Engineering is fun. It's exciting and creative, and the community is so supportive. The lecturers are always encouraging and always willing to help if you're struggling. If you really like problem solving and working through tasks, this is the course for you.
Okay, we hope you enjoyed the tour of the electronic engineering facilities there. We're now going to take you down to the basement, which houses our engineering workshop, 3D printing facilities, and a range of other facilities here at Dublin City University. Okay, we have a wide range of engineering courses here at Dublin City University. For those who are a little bit unsure of what course to take, we have a common entry to engineering. And this is a very good course for an introduction to the various engineering courses that we have. We also have 2 schools of engineering, as mentioned before. One is mechanical and manufacturing engineering. They offer a B.Eng in mechanical and manufacturing engineering, and also a B.Eng in biomedical engineering. Our electronic and computer engineering course is also available to students, and then we have a bridging course that bridges across the 2 schools. This is our mechatronics course, and it is a mixture of mechanical and electronic systems. This year in the CAO we have 2 new courses, Sustainable Systems and Energy, and this is a very interesting course for those who want to have a look at the grand global challenges of climate change, energy solutions, and so on. And then we also have Global Challenges, which is a new course in the syllabus this year. We'd now like to cut to a video to show you some content around the mechatronics course that we have on offer.
More and more aspects of the world around us are becoming automated, with always-on connected devices and robots able to perform tasks quicker and more accurately than humans. These machines are staggeringly complex, with huge numbers of finely tuned moving parts being precisely controlled in the blink of an eye by state-of-the-art electronics. Just consider the machines you use on a daily basis and how many moving parts are involved. Such machines are examples of mechatronic engineering, the science of combining mechanical, electronic, and software engineering to create intelligent machines. The potential in this area is immense, no matter what your interest, from building labor-saving intelligent robots to interfacing the mechanical and electronic parts of future renewable energy systems. With state-of-the-art labs, small class sizes, and industry-relevant modules, mechatronic engineering at DCU is a trailblazing course.
We'd now like to welcome you to the engineering workshop. A number of our students spend time in here with senior technical staff designing, building and constructing projects. So I'll take you through the workshop now. This end of the workshop is mainly manual machines. So we have drills, we have lathes, we have milling machines, and they're semi-automatic machines. And again, students would come with their design projects. They would get some feedback from the technical staff that work in this workshop, and they would start to re-enhance their designs and come up with better components for their final year projects and their master's projects. I'll take you through now to the automatic machines in the workshop. We're very proud of this workshop. We feel it's one of the best workshops in the country, and students have good access to the staff within this area. One of the most recent machines that we installed in this workshop is this particular machine, which is a 5-axis milling and drilling machine. So what we have is various components, again, that are manufactured within this particular space. So we have cutting tools that are used within the actual machine itself, and they automatically load in and out of the actual machine. And to give you an example, if you take a bar of material like this machine can construct this particular component within about 2 minutes. Okay, so it's a 5-axis milling machine, and it gives very accurate movement within the actual machine itself. At this particular point, I'd like to take you through to our 3D printing suite to give you an example of some of the activities that happen in that area. This is our 3D printing suite, and I'm going to hand you over to Tara McMullen, who was one of our students that came through our engineering courses, to give you an example of some of the activities that happen here.
So engineering students at DCU have access to a wide range of 3D printers. 3D printing is an additive manufacturing process, so it has become one of the key technologies in engineering at the moment. So you can create really complicated pieces on a computer and then have them fully built by a fully automated manufacturing process. So they can be used for a wide range of things, from something really small in, say, the fireman project, or designing end effector limbs for prosthetic limbs, or for full FYP. So the final year projects are really complicated kind of design pieces can be printed. At the beginning of this pandemic, DCU responded to the call for PPE for frontline healthcare workers, and this 3D printing lab was converted to a production hub for glasses and face masks for healthcare workers.
I'd like to take you down and talk to you a little bit about the automation and control suite that we have also in this laboratory area. You can see some cameras here, which give you an indication that these are virtual labs. So during the actual pandemic, we had to automate our labs, and we allow students to work on the labs virtually. So they can sit at home, they can control things, and they can get things to happen in the DCU control suite. So an example I will give you here is a ball in a tube. So let's say I say to you that at the end of the day, we want you to control what's happening with this ball. And let's say as a student, I said to you, I will give you €1,000 if first time you can move that ball from 0 to 775 millimeters up that tube. In order to do that, you would need to understand the control mechanisms that you have in place, and you would need to know about sensors. And that's a typical example of the mechatronics program that we have. So we have an ultrasonic sensor at the top of this tube. We also have a fan at the bottom of the tube, and based on the information we're getting from the sensor and the fan speed, we can get accurate control of this particular ball. Now that might sound simple. It's one of the hardest things that you can do, is to get accurate movement of that and position it to a certain point. Why would you want to do this? Let me show you an example of a biomedical application of this particular scenario. So on the screen here, we have a patient. The patient here has Parkinson's disease. The patient, we want to do an accurate drilling of the skull in order to implant something that will assist with the Parkinson's disease. At the end of this particular robot arm here, we have a tiny 1 millimeter drill that is going to drill a hole in the cranium. And on the basis of the type of control that I was talking about that we teach you, we can accurately move this arm and position it so as that we get an extremely accurate movement of the actual drill piece when we're dealing with this patient. And we interact with surgeons in Beaumont and various hospitals in order to accurately control their particular robotic surgeries that are taking place there. At this point, I'd like to thank you for joining us today. I'd like to welcome you maybe in September to the new programs and the existing programs that we have on offer at Dublin City University. And if you need further information on any of those programs, please join us on the website at DCU and Engineers Week. Thank you very much.